Actually, sorry, take that back. Before I do that, if you have this yellow guy, would you get this out? It says AP Calculus Practice Test, AP Test Part 2 Greenway on it. You know what I mean? I just gave it back to you. Here's my problem. You did the first part of this practice test the first or second week of the semester, and I recorded if you did it, but I didn't record how you did it. So that means you have it, and you should. I don't even know what color it is. Is anybody super organized to know what Greenway Part 1's color was? It was blue? Okay. You might, if you, just for the fun of it, if you're organized and you have that, get out the blue Greenway, and then the yellow Greenway, and let's do a progress check here. So, the multiple choice, I believe there were 10 multiple choice on the blue and 10 multiple choice on the yellow. So you should get a total. Why did I say plus out of 15 here? Forget that. Never mind. Sorry. Your multiple choice is just something out of 10 on the yellow and something out of 10 on the blue. Did I give you a... Yeah. So, hold up. How many you got right out of 20 on the multiple choice? Do you have that for me? Sorry, I'm all over the place. You good? Now, if out of 20, you're at about at the 2/3 level. So if you're at, let's say, let's go with 14. Greater than or equal to 14, then you are good at multiple choice. You're on pace for a 5 multiple choice style. Okay? Keeping into account, first of all, you're working together, so that's a plus in your favor. But these problems are actually harder than the AP because of the algebra involved, so that's against your favor. So it's about a wash, okay? The free response, it's out of 36. There are 4 questions so far. Again, 2/3 of that. If you are greater than or equal to 24, or in other words, averaging a 6 or so in the free response, then again, you're on pace for a 5 free response style. Now, hopefully, you're on pace for a 5 for both. But if not, then you need to say, wow, I need to work on multiple choice and or free response, whatever the case might be, and I'll be happy to help you. Are you with me? Good? Sorry, I failed to record those, so I don't know who you are. I have to trust you. Okay. Questions, or not questions, sorry. Back to the lesson. Here we go. I'm already recording it. Boom. Okay. This is actually a really big problem set. They probably should have broken it up into 2 sets of these. So I introduced you to differential equations yesterday. We just practiced solving a differential equation by separating and integrating. But let's go with the most famous differential equation in all the world. Okay, it goes like this. This is the most famous differential equation in all the world. Y prime equals K1. And I will explain what the heck makes it so great in a second. But let's start here. Joe starts with $10 and earns 10% simple interest every year. This is a pre-algebra problem. Lou starts with $10 and earns 10% compound interest once a year. Complete the table for each person. So, Joe, at the start of the year, how much does he have? $10. If he earns 10% interest, how much interest does he earn in a year? 1. So how much does he have at the end of the year? 11. He starts the next year with $11. He earns 10% simple interest. So how much interest does he earn the second year? $1. It's always based on the original amount, not on the new amount. There is no compounding, no rounding, or taking the amount earned into the equation. It's always on the initial. So every year he earns $1. If you think about the graph of that, if every year this money goes up by $1, then the graph of that is linear. Okay? You could say that his amount changes. Now, if you wanted to do this as a differential equation and challenge your mind here, what's the differential equation here? The rate of change is always 1. Okay? It's simple interest. It doesn't matter what time it is. It doesn't matter how much he has in the account. The rate of change is always growing by $1. You follow? Now let's go to a little more complicated case of Lou. He's earning 10%. Now I'm not talking compounded all the time, continuously. I'm just introducing this with compounded once a year. So after 1 year, how much does he earn in interest? $1. And how much? $1. How much does he end with? $11. That means he starts year 2 with $11. But in the second year, how much interest does he earn? $1.10. And so how much does he end the year with? $12 and 2 nickels, or 10 cents. That means he starts year 3 with $12.10. How much interest does he earn his third year? $1.21, which means he ends with $13.31. You can see the difference is 31 cents in interest, and that's because he earned interest on interest, right? Now then, it seems like here the rate of change is varying. At year 1, it went up by $1. In year 2, it went up by $1.10. In year 3, it went up by $1.21. So because the slope between points is getting bigger, this curve is concave up, and it's curving. That is, then, exponential growth of the sort. Now, Lou's money, then, changes at a rate proportional to the amount. His rate of change in his amount isn't constant. It depends on the amount. Now, students don't always necessarily appreciate how kooky that is. That is a derivative dependent not on the independent variable time, but it depends on the dependent variable amount. The rate at which it grows depends on how much you have in the account. That's really crazy. That's like saying dy dt depends on y, not x. That's what makes this a differential equation kind of problem. Normally, when we do, if we were to do crazy old Newton's stuff, the derivative has to be in terms of x. It can't be in terms of y. But Leibniz, sometimes you get a derivative that's based on the independent variable. In fact, this is the most famous differential equation of all. Why is it so famous? Well, let's check it out. Say dA dt is proportional to the amount. Let's start there and use our skills from yesterday to find the amount equation. Get rid of the derivative idea. What do we do first? Separate the variables. So the dA and the A need to go together. K is a constant, so it can move, it could stay. I'll just keep it on the right-hand side and group it with the dt. Do you follow? If I integrate both sides, what's the antiderivative of the left side? Natural log of the absolute value of A. Absolute value of A equals, on the right-hand side, if you have to differentiate the constant K with respect to time, what is it? KT plus a constant C. All right? Now, for this, usually A is positive. These are usually money problems, or I'll talk about the others. So we're gonna dump the absolute value for the time being. All right. So the natural log of A equals KT plus C. You track it. All right. What is, now normally then we would find C by the initial condition they give you. It's pretty common that they ask you to use this kind of general initial condition. The initial condition, you use the fact that at time equals 0, A is the initial amount. Whatever that initial amount is, the amount is A initial. If I plug that in, then the log of A initial equals K times 0 plus C, and therefore C is just natural log of A initial. You follow? All right. Now let's go back and plug that in. Natural log of A equals KT plus natural log of A initial. Now we need to solve for A. How do you get rid of the A, or the natural log? E. If you exponentiate, do I exponentiate, do I E here, E there, E everywhere, or do I E the whole side? You E the whole side. All right, now here's where we need to use a little bit of algebra skills. Would you go off to the side and remind me, in Algebra 1, when you had a base with a sum in the exponent, what is it the same as? X to the, yes, it's equal to x to the fifth, that's true, but isn't it equal to x squared? Is it x squared to the third or x squared times x to the third? Times x to the third. Do you recall that? Now, typically in Algebra 1, you went this way. I gave you this problem, and you added the exponents to combine it, right? Here, we're actually going to do that in reverse. E to the sum is equal to e to the kt times e to the log of A initial. What is e to the log of A initial? A initial. So why is that differential equation so famous? Because that's where exponential growth comes from. The exponential growth equation you learned first in pre-calculus, or actually in Algebra 2, comes from this differential equation. Okay? Now then, this is, the big idea of this side here. There are three facts that all intermesh and go between each other. If the amount changes at a rate that depends on the amount, or depends on the y, or the a, whatever, then that implies that the differential equation is this. The rate of change is proportional to the amount, but after all that process, and you don't have to do all that process every time, if you see this, it's got to be the case that this is growing exponentially. Now, students, we just did this direction. We showed why it has to be the case if you separate the variables and integrate, you end up here, right? If you have your eyes open, you might think, well, how does this work? If I take the derivative on this with respect to time, it seems like I don't get that. Well, how is that happening? Well, the derivative of the left is dA dt. Cool. The derivative of the right. What's the derivative of the right? A initial, constant or variable? It's constant, all right, so boom, A initial. What's the derivative of e to the kt? Be a chain rule. What? E to the kt times k. All right, cool. So it seems like dA dt is A initial e to the kt times k. But what is A initial e to the kt equal to? It's A. So if you substitute what A is in for itself, then you get that. Right? So it makes sense. All right. Here's what some smaller free response questions will look like. Bacteria in a certain culture increase at a rate proportional to the number present. All right. If the number of bacteria doubles every blah, 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 Now, this has a slow, you might feel like, haven't we done this since Green Book? Well, no. Nowhere in this problem does it say the amount grows exponentially. It doesn't say that anywhere. It's implied by this. If the amount grows at a rate proportional to the number present, that means dA dt is constant A. And we know that that implies the exponential growth relationship. Now, you don't have to show all the integration to get there. You just need to recognize that that statement in English means that differential equation. And that differential equation leads to that amount equation. After that, it starts to behave like a pre-calculus problem. The number of bacteria doubles every, what does it say? Every hour? Does it not tell you that? Right? Not 4? It says 4 somewhere? Oh, okay, cool. All right. Doubles every 4 hours. How many hours will it take for it to triple? Okay. So I want to eventually find a time. How do I use the double E thing? What does the double E thing imply? That the amount after time is double the initial amount, and that happens when time is 4. From that, I can solve for t or k? K. K is k-specific. In this case, then, 2 equals e to the 4k. Natural log of 2 equals 4k. So the k for this problem is natural log of 2 over 4. Yay? So if I want to know then how long it takes to triple, what do I put into the equation? What am I looking for if I want to find how long it takes to triple? T. Okay, so what do I put in? What's the amount after time? 3 times the initial amount, yay? If it's going to triple, then the amount after time should be 3 times the initial amount. E to the k we know now is natural log of 2 over 4, and t is to be found. Solving that for t, what would you do first? Right, divide the initial over. We're back to that same no participation kind of thing. So, tell me your answer. T is? Natural log of 3 divided by the k factor. Natural log of 2 over 4. Yeah? All right. And whatever it is, it better be more than 4 because it doubles in 4, so it's got to triple in more time. All right, let's go to another case here that you might see. Temperature F changes according to the differential equation dF dt equals Kf, or the rate of change in the amount is proportional to the amount. K is a constant, T is time in minutes. The idea here is if you're going to find K, you don't want to work in this equation because all of these are not dF dt facts. They're F facts. So you need to take this statement and make it an F equation. What does dF dt equals Kf imply? If dF dt equals Kf, then in this case we're talking about that differential equation, so it must be the case that it's exponential growth, but instead of A, we're just using F. So F equals F initial e to the kt is what goes with that fact. Now I can use what they give me and find what they ask. It says at time 0, F is 180. What does that imply that we know? F initial is 180. Boom. Okay? Using that fact, we've got F initial. Now we need another case to find the K, because K really represents how it changes over time. So we need a second case. They're giving us a second case. At time 16, F is 120. So if I use that fact, that time 16, F is 120, that would allow me to find K. And it would be something like, what, 2/3 when I divide 180 over, take the natural log of that, and divide by 16. So there's, all right. And then this had multiple choices actually, but I skipped them all. That is the introduction. Now, would you go to the back and give that a go? Actually, that's part of your homework. So, the back side is part of your homework, and I will check. So, my intention is this, I guess. This front side is supposed to be your notes. I didn't want to print 3 pieces of paper. I could have, I guess. But this is your notes, so I don't want to collect part of your notes. So tomorrow at the start of class, I will check the back for 5 points of homework, and I'll collect the other page for the other 5 points of homework. Do you understand? Okay, cool. All right, questions on set 88? 88 questions. If any. 8?
8 and 23. 12.
8, 23, 12, 24.
16.
16, 25,
21.
16, 25, 21. The last replace.
The last one, 21.
Oh, so the white sheet needs to be completely done, and the back of the pink sheet needs to be done tomorrow, yeah? 10-4, good buddy. There's a lot of space there. I just wanted you, mostly it's just a couple free response problems. They should, that white sheet shouldn't take but 30 minutes. What am I at? That's 87, 88. All right, here we go. I forgot 4 points. Sorry about that. Is 8 still a question?
Yeah.
Cool. All right, here we go. 8 is not replaced, it's figured by the books.
No, I know, like 10-4, but like, no,
All right, this one requires you to get your little decoder ring and
no, it's like,
decode English into calculus. It says the slope at any point is 3 times the value
no, it's like 18.
of the x coordinate. What does that imply in calculus? How do you find the slope at any point? The derivative. Now you could have put f prime in the spine. I used dy dx because I was in differential equation state of mind, but it means the derivative is 3 times the value of the x coordinate. So the derivative is 3x. Okay. They also tell you the graph passes through to 3, and they want, what is the equation? Okay? So, how do I get rid of the derivative and start to get the equation? Separate the variables so you can integrate properly, yeah? So y is 3/2 x squared plus c. Now you can go off to the side and use the 2, 3 to find the c. Once you have the c, you can come back and write your final equation. Okay? So that, the hard part was the translating the English into calculus. So that should get you started. 23. 23, should I give you a minute or should I go? Okay, 23, I have a little warning for you. This is actually a later lesson, that's going to be a mean to you, but did I write your notes? No. Okay, you absolutely 100% cannot use L'Hopital's rule for a product. It does not apply to a product, it must be a quotient, period. Okay? So if you thought 0 times undefined is undefined, no. You must make it a quotient. How do you make this a quotient? Like that. Now you're talking L'Hopital. The limit as x goes to 0 of x is 0. Limit of x goes to 0 of sine of 3x is 0. So by L'Hopital, you can evaluate the limit of 1 over 3 cosine of 3x at 0. Okay, you must make it a product first, or a quotient first. Do not take derivatives on a product. 12, question on 12. Is 12 still a question, somebody? Okay. Find the volume of a cube decreases at a rate of 6 cubic meters per second. I hope you took the given and put it into calculus. dV dt. Volume is changing with time. That's a rate of change. Decreasing. So it's a negative rate of change. 6 cubic meters per minute. They want they want the rate at which the edges are changing, so I'll call it the x dt when the volume is 64. Okay, so boom. I can't find the x dt and use dV dt unless I have a Vx equation. What is a volume equation for a cube? X easier. If it's a cube, then it's just x cubed, right? If I differentiate with respect to time, because it's related rates, we take a derivative with respect to time. What's the derivative of the left? dV dt, and the derivative of the right. Keep in mind we're taking a derivative with respect to time. We have x squared, but then by chain rule times the derivative of the inside, which is the x dt. There's chain rule for this when you differentiate with respect to time. Okay, if you substitute in what you know, negative 6 equals 3 times, what is the x at the instant they talk about? They say find the dx dt when v is 64. Well, if v is 64, then that implies x is 4. So dx dt, you can solve that. B, find the rate at which the surface area is changing. They want ds dt or dA dt, whichever you prefer, when at that same instant when x is 4. Okay, I can imagine two different surface area equations. 2 times the area of the base plus the perimeter of base times the height. That applies to all prisms. For a cube, it might be a heck of a lot easier to use 6 times the side times one side, yeah? Pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
All students, please come and support the boys swimming dive team on Thursday, February 28th at Chick-fil-A at Bellevue Shores, 5260 South Wadsworth Boulevard, from 4 to 8 p.m.
Just stop.
Don't forget, there's still time to donate to the Wish campaign for 3-year-old Alex.
Let's pull you
Until February 28th.
I guess I should just stop pushing the button.
Do you like Starbucks? What about free Starbucks? If so, submit your best Devlin Dash t-shirt design for the upcoming 2019 Dash. Simple is better. We can't include too much detail on the
Okay.
If you're designing
So,
to make
it's easier to use this one, differentiate that with respect to time,
to the front office by February 28th.
and you'll use your answer here
Interested in traveling to Europe in the summer of 2020?
for part B.
You're in luck. We're available with
Okay?
students to Italy, France, and Spain in June 2020. And Ecuador will be taking a group of Catholic students to England.
24
Most features will start in the meeting today, February 26th, from 6 to 7:30 p.m. Come find out about
is a
both
table problem.
potential travelers and their parents should attend.
Find the time if any of the part passes
The
through.
University of Colorado at Colorado Springs will be in counseling today to assist admitted students who are inquiring about their next steps, and juniors and sophomores who want to know more about UCCS. Make sure you stop by counseling or sign the college visit book and sign up on the 7-hour app.
Senior high students.
So I guess if you're a Weisenheimer, in part A it says find a time when x equals 0, you might say
Address for the 1920s.
there, right?
Meetings will be
forgot me. I forgot to say what I wanted. So find a time other than time 0 when x is 0. Well,
All winter
by
athletes,
IVT, you shouldn't
your
it
athletic lockers and turn lost in the
in here?
Italia
Something like x is continuous and x equals 0 is between x of 1, which is negative 7, and x of 2, which is positive 8.
Heads up, 8th graders. This
So
week
by
is
IVT,
today, if your last
there's a
name
time
is Fortin to Lofty, please come to the auditorium during 7 hours. Tomorrow,
in
last
1 to
name,
2,
Medalla to Royale.
There's 5
and x
new
equals 0.
middle school tennis, which starts on Monday, April 1st.
B.
Practices will be at various locations throughout the week, with matches on Saturdays. We have all those
And the particles at rest. At rest implies v is 0, yeah? Okay, v is 0. I don't have v, I have position, so v is change in position. So really this means is x prime equal to 0, which implies we need to use the MVT, yeah? My goal would be to say, is there some time when the positions are the same in the table, but they don't have any positions in the same in the table? Does that mean it doesn't happen? Well, no. Didn't we just prove that there's got to be a time in here where position is 0? Right? And we just showed that. So over that interval, doesn't the overall average rate of change have to be 0 on that interval, and therefore there's got to be an instant? So I would say we just showed there is some other time when x is 0, and x is both continuous and differentiable. So by MVT, there is a time in 0 to 2, somewhere from here to here, when the velocity, which is the derivative of position, equals the difference, change in position over time, and that is 0. So that's how I did it. I don't know about you. 16. We figured this by the end of the day. You can always sign up for 7th hour if you have 8 questions. That's a possibility. That's why they have 7th hour. Have a nice day. Oops. Buenos dias.